Hey everyone, this is Unit 1, Lesson 6. EQ is how can we apply the properties of integer exponents to generate equivalent numerical expressions. LT is I can simplify and write equivalent expressions that contain negative exponents. The two verbs are going to be simplify. We're going to simplify expressions, and we're also going to write equivalent expressions. And today specifically, we're going to be learning about negative exponents and what we're going to be doing with those negative exponents. All right, the brain starter is us applying previous rules that we've learned. We should know that this one we see division, so this is the quotient rule. This is the quotient rule, so that means we are going to be keeping the base and subtracting the exponents. And we see that we are left with a negative exponent, and we're going to talk about exactly what we're going to do with that during the mini lesson. Right here we see two powers multiplied with the same base, so this is the product rule. We know that with the product rule we're going to keep the base and add the exponents. 3 plus negative 6, and that is going to be giving us 5 raised to the negative third power. And again, we're left with a negative exponent, and it's just for us to see that we can get negative exponents, and in the mini lesson we're about to check out what we're going to be doing with those. Alright, so in this mini lesson, let's make sure we have this whole table copied down. This is an extension of last lesson, so Unit 1, Lesson 5. Going from left to right, we said that we were dividing by whatever the base was. So from 25 to 5, we were dividing by 5. And then from 5 to here, we know that anything raised to the 0 power equals 1 from last lesson. So that means we divided by 5 again. Notice how the exponent changes from 0 to negative 1, right? Every single time that the exponent decreases by 1, we're going to divide by the base. So if we continue this pattern of dividing by 5, 1 divided by 5 is equal to 1 over 5. Or in this case, 1 over 5 to the first power. So this is going to be 1 over 5 to the first power. And if we continue that trend of dividing by 5, because again the exponent decreases by 1 again, if we plug into our calculator 1/5 divided by 5, so we have 1/5 divided by 5 equals 1 over 25. So 1 over 25. Why is this relevant to us? Because we know that 5 raised to the second power is equal to 25. So another way of writing 25 would be 5 to the second power. So in other words, it would be 1 over 5 raised to the second power. Alright, if we continue this pattern but with a different base, we're going to be dividing by 4. Divide by 4. 1 divided by 4. We're going to be left with 1 over 4. And then, well, technically that's 1 over 4 raised to the first power. And if we divide by 4 again, we're left with 1 over 16, or 1 over 4 raised to the positive second power. And then the last time we're going to be doing this, we're going to be divided by 3, because 3 is our base. Divided by 3. Divided by 3. 1 divided by 3, we're left with 1 over 3 raised to the first. And that means that we're also going to be dividing again by 3. So now we're left with 1 over 9, which is really just 1 over 3 raised to the second power. So if we take a look at this last example, 3 raised to the negative second power equals 1 over 3 raised to the positive second power. All we can really say, if we were to use this as our rule, okay, for a general rule whenever we're dealing with negative exponents, is that whenever there is a negative exponent, we're going to turn it into a fraction. So it's going to be 1 is always going to be our numerator, and we're just going to write this exact base underneath here, but with a positive exponent. 1 over a to the positive n power. All right, if you need to pause this video and make sure that you copy all this down. I know that this was a long mini lesson, but just pause this video and make sure that you have all this copied down into your Cornell notes. Moving along to the next part of our mini lesson. How can we apply the rule for negative exponents? When a power is raised to a negative exponent, the power can be rewritten as a fraction. The power becomes the denominator, which makes the exponent positive. So in other words, let's come up with an example. Let's say we have 7 raised to the negative second power. Another way we could write this would be 1 as our numerator always, and then we would just change this negative exponent to a positive. It would just be 7 raised to the positive second power. Let's try with the variable. If we have, let's say, k raised to the negative fifth power, another way to write this would be 1 over k raised to the positive fifth power. All right, and going back to the brain starter, if we were to just use this as an example, so we're using the product rule. So we had 5 raised to the third times 5 raised to the negative sixth. We know that this is 5 raised to the negative third power, so our real answer would be 1 over 5 raised to the positive third power. We never want to have a negative exponent. And we're going to talk about that in our next question, which we're going to copy down as well. Why do we need to apply this rule? When we are simplifying expressions, we always want to use positive exponents in our answer. We never want to leave an exponent negative. If we do end up with a negative exponent, then we must apply this rule, which means that we need to make it positive. All right, so make sure that we have all this copied down in our Cornell notes. Pause the video if you have to. The work time is not just us practicing us being given a negative exponent. We have to actually apply these rules. So this is going to be the quotient rule. This is going to be obviously the product rule. And I want to see what everyone does for number 3. This is an extension problem. This is actually a New York State question. And let's see what we can do with number 3. We're going to review the answer to tomorrow in class, or whenever we are in class together. All right, make sure we copy that down and we answer those questions in our Cornell notes. The closing is what we usually have for our closing. What resonated with you in today's lesson, and what questions do you still have? If you have any questions,